Hello. Today we are going to see how to do the equipment modeling in piping in Caesar 2 after completing the piping modeling. So once you complete the piping modeling, then we need to do the equipment modeling in order to get the thermal expansion of the equipment at this nozzle. So now today we are going to see the equipment modeling for this nozzle. This is based on the 3D model. We need to check the configuration of the equipment. Yeah, now we will consider like this in east-west direction, like plus Z minus Z. This equipment is placed as per the 3D model. So we are going to model as per the equipment vendor drawing. So for this, this is a reference 3D model. This is for other projects, not for this project. You see, this equipment is placed in north-south direction, and if you are going to model this line, then you have to model the equipment accordingly. Okay. So in this case, our equipment is placed in east-west direction, so we are going to model accordingly. For that, first we need to check the isometric drawing where the nozzle, where the equipment is connected, means equipment nozzle number you can refer. So here equipment nozzle is C, the equipment. So please go to the equipment window drawing. So this is nozzle number C. Go to the equipment window drawing. So this is equipment window drawing. You can see many nozzles are available. So our nozzle is C at the center of the equipment. You can see at the center of the equipment. So C is our nozzle. So for this, what we need to do? We need to check the nozzle table. So in the nozzle table, you can find all the nozzle details, like what is the nozzle name, nozzle size, rating, and what is the nozzle thickness. Everything, it will be material, everything it is provided in the nozzle table. So our nozzle is C, that is 14-inch 150 rating, and thickness is 19.05 wall thickness. So first what we need to do, we need to select the node number, that is node number 20. So in that restraint is there now. So in the node number 20, after this we are going to model in the downward direction, minus Y direction. So we enter 21 as C node. You can give any node, but for our easy reference we are considering 21. You can get 10,000, 20,000, something like that you can give, but for our reference we are going to give 21 as C node. And go to the lowest element, control end. If you press control end, it will go to the lowest element. Yes. And go to the next node. Yeah, next node. So what is the nozzle size? Nozzle size is 14-inch 150 rating. So first we need to model the flange, that companion flange, where it is getting connected to the pipe. After that small spool piece is there, that also we need to model. Okay, so for that we need to refer the pipe data pro to get the flange weight. So please open pipe data pro, and 21 I am giving a 10,010 as the node number, to node number. From node number it should be our C node, whatever provided, no, that one. And then size, nozzle size is 14-inch and thickness is 19.05 mm. Yeah, this is very slow, so I am going to close this Navis file. Yeah, you see in the C nozzle, that is 14-inch nozzle and 19.05 mm thickness. So we need to enter 19.05 mm wall thickness. Yes. And then you need to enter the corrosion allowance value as per the vendor drawing. So in the right side you can see you'll get all the design parameters as well as the material and corrosion allowance in the design data. Below design data you can find all the details. You see design temperature, design pressure, corrosion allowance, it is given as 3.2 here. So we are giving corrosion allowance based on the vendor drawing. And then material, and it is check the material. So here you can find the shell material is provided. Shell means equipment material. That is A516 grade 70 it is given. And pipe material it is given as, let's say below you can find pipe material as A106 grade B. Nozzle piping, SA106 grade B. So we can give the same material in our model. Yeah, press you have to give just 106 means you will get the material. Yeah. And then fluid density, same density we are considering. And temperature is 200, that is design temperature, operating temperature 160, and minimum design temperature 0 degree. So 200 degree, 160 and 0, yeah, design and operating is okay, but minimum design temperature we are giving as 0. If you give 0, then you will not get the thermal expansion. So instead of 0, we are going to give 0.1. So 0.1 if you provide, then you will get the values, thermal expansion values. If there is no thermal expansion, then your output will not be correct. So 0.1 I am giving, and you will get the thermal expansion. And pressure, it is 7.5 full vacuum. So the same pressure what we have considered for the piping, it will be considered here also. 7.5 into 9.81. And the hydro test pressure also, same hydro test pressure we are going to consider. Design pressure into 1.5. Okay, then insulation density and insulation thickness, same we have followed for piping, we will follow here also. So then Pipe Data Pro, open the Pipe Data Pro for 14-inch 150 rating, you will get the dimension of 127 and enter the value 127 in dy minus 127 because we are going to model the equipment from top to bottom. So minus 127. So you see small pipe it is appeared. Then you have to double click the rigid. And you get the weight from the Pipe Data Pro. Stud bolt weights, flange weight plus stud bolt weight. When you need to add both, then only you will get the correct weight. You can use Caesar database flanges also, but In Caesar database, they have not considered the stud bolt weights. So what we need to do, we need to refer from pipelet approach, and for more conservative approach, we are considering stud bolt weight also. Just calculate 50.5 plus 11.04, so we will get 61.54 kg. So I need to convert into Newton, 61.54 into 9.81. So I mean, you can round it off to any nearby values. Okay. And then you can give equipment number if required. You can provide the equipment number for easy reference, because in some cases what we have more number of equipments, not only one equipment. More equipments will be there. For easy identification, if we provide the equipment tag number, it will be easy for our reference. Okay. Then go to the next node. So we have modeled the flange. Next, in the nozzle neck, you can find small spool piece. So in order to get the small spool piece, you have to refer the vendor drawing for nozzle projection, for that particular nozzle C. Yeah. So generally in nozzle table, they used to project a nozzle projection. In some cases, they will not provide. So in those cases, what we need to do, we need to refer the drawing. You see, in the left side, you can find the nozzle projection, C. It is given as 1452. So what, in order to get the nozzle neck dimension, you have to subtract the radius of the equipment from this value. So for radius, you need to refer the equipment OD, outer diameter of the equipment. So here you see, it is given 2438 is your outer diameter and 15.9 mm is your thickness. So if you want to get the radius, OD divided by 2. That is 2438 divided by 2. One 1219 is the radius of the equipment. So get the nozzle projection 1425 minus 1219. $206 is the nozzle projection dimension. So out of 206 we have modeled the flange. So we need to subtract this one, 206 minus 127. 79 mm. You will get the spool piece of 79 mm. So you need to enter minus 79 here. Yeah. And then what we need to do, you have to consider this as an anchor in order to get the nozzle forces and moments. If you are not anchored at this location, you will not get the forces and moments. So in order to get the force and moments, you have to consider this as a restraint with anchor. So generally the nozzle forces and moments will be checked at this junction. Some cases they used to check at that node number 20, but for conservative approach we are going to check the nozzle force and moments at this location only. And anchor, enter as anchor, and give C node also you have to provide this, because we are going to continue the model till the fixed saddle support. We'll go to the next element. And you need to change the from node number as C node. So now up to here we have modeled, and we are going to model till the center of the equipment, and then up to we are going towards left side. You see there are two saddles, so you need to check which saddle is fixed and which one is sliding. So in the you see below they are provided fixed and sliding they given. Okay, so left side is a fixed one and right side is a sliding one. Now we are going to model for till the left side. So the dimension from the center of the saddle, center of the equipment to the saddle is 4,888. Now we are going to model this vertical portion, that is your radius of the equipment. This is minus 1219. Enter, and you will get this like spool. And from this point onwards, we have to enter all the equipment parameters and equipment details. OD of the equipment and thickness of the equipment. 2438 is your OD and 15.9 is the thickness. And then you need to change the material. So the shell material it is given us already we have seen A516 grade 70. So this is also a carbon steel, but it's a plate type material. So for equipment always plate type material only will be used, except the nozzle other places plate type material only will be used. Sorry, the system is very slow. Yeah, up to the center of the equipment we have model. Now we are going to model till the fixed point of the saddle. So you need to go towards left and then again downwards till the outer edge of the equipment. Yeah. And some companies, what they will do, they will model till this point, and they will use to provide the equipment support here itself. If it is a fixture, they will consider anchor. But most of the company, what they will do, they will model till the saddle location also we will model. Saddle height also we need to model. So you see the dimension it is given us 4,888. Sorry, it was not saved, so again just I will model the unsaved portion, the nozzle neck as well as the piping. Yeah. So now it is anchor we have provided. Yeah, you need to give rigid. After this, you need to give rigid without weight. Some companies, what they will do, they will model like a cylinder, but most of the companies, they are following rigid without weight. A516 grade 70. The material has to be changed. So why we are modeling the equipment means to get the exact thermal displacement. In power plants and all, what they will do, they will not model the equipment. See, the dimension is 4888. They used to consider the thermal displacement based on the equipment vendor drawing. At the nozzle junction only, nozzle shell junction. So you see 4888 in plus Z direction you consider. It should be rigid without weight. Yes. And then go to the next element. Okay, now go to the next element. So now we are going to model the downward portion, that is the radius of the equipment, that is minus 1219, and dy it is minus y direction. Okay, go to the next element. Yeah, from here up to here we have modeled. Then again we need to model the saddle. So in order to get the saddle height, you just refer the left side view of the equipment. You see, left side you find the wave. Yeah. So this is the overall height from the center of the equipment. So you need to subtract this value from 1785 minus the radius of the equipment, 1219. You will get the saddle height. 566 mm is our saddle height. So you just model minus 566 in dy direction, minus dy. Yes, minus 566 and make it as rigid without weight. So generally saddle is subjected to atmospheric temperature and pressure. So there will not be any fluid flow in saddle. So what we need to do, we need to consider ambient temperature and pressure for the saddle. Okay, you see the small portion. Yeah, the saddle. So we are considered as anchor, restraint, anchor we are provided. Because since it is a fixed saddle, we are considered as an anchor. So what we need to do now, we can model either the sliding saddle or you can leave like this. So now we are going to model this one. Since this is a mirror image of this, so what we are going to do, we'll copy this 10,050 to this saddle. Okay, and you see, I didn't change the temperature, so please change the temperature to ambient. So whatever ambient temperature applicable for this project you have to use. In some cases 5 degree may be our ambient temperature, so here you have to enter as 5 for all the 3 cases. And if it is 40 degrees our ambient temperature, you need to enter 40 degree for the saddles. And pressure you may consider as 1 or either 0. 1. Or you can consider as 0 also, not an issue. It will not have an impact in the analysis. Now if you check, yeah. So now what we are going to do, we are going to model the fake sliding saddle also. Sliding saddle, it is in the minus z direction. So from 10,050 to the fixed saddle, we will copy. So go to the list inputs. So input listing is either at left side top or sometimes will be at the bottom. So at the last node, what I'm giving 10,050, and then this 2 node number you can give 10,150 or 10,200, anything you want. That should not be the repeated value already used in the model. So either you can model manually also, minus z. If you want to model means minus z, in the minus z direction, 4,888. You see the distance from center to there is minus 4,888. Yeah, this is a list inputs. From this, you select elements. You see, on Excel kind of thing is opening. So you copy from 10,050 to the saddle end. Right click. So you see your cursor is coming, that in the left side, that black arrow will be appear. So you have to pull that black arrow, select, and select all the rows. Yes, and right click, block operation, duplicates. This is to copy any element. So here you can see identical element and other. If you want to mirror, you can mirror it. And I am giving this one as node increment as. So any node increment you are giving, I am going to give 100 as node increment. So 10,050 plus 100, you will get 10,150 is your start node. Okay. Then press OK. Yes. So you see our number has been appeared, 10,150. So I need to change the start point because our start point should be, from node number should be 10,050 only. So what we need to do, we need to change that one manually. Either here you can change or go to the model, you can select that particular node, you can change. So if you have any doubts, please let me know. Please do comment on this video so that if you have any doubt, I will get it clarified. Okay, now you see, if you select this one, select this. Yeah, this is 10,050. So you can change this one to 10,150. I need to change this direction dz as minus 488. Yeah, minus 488. If you enter minus 488, you will get the equipment in the minus z direction. Yeah, you see. Yes. And you can see since we have copied this one from the previous node, the parameters used in the previous node will be appearing here. You see, we have model, but we are not given the dimensions, so we need to delete that node. So you just delete, select node and delete. It will get deleted. Yes, it has deleted. So since we have copied from the this one from the previous node, so whatever parameters provided on the last element, that is saddle, that will be continuing here. So in order to change that one, because we have given 21 degree, that is ambient temperature we have provided. So you need to check the temperatures. If you check the temperature, you can see the difference. It is appearing the same temperature for the what we have used for saddle. So we need to check, and you have to correct here itself. Otherwise your result will be wrong. So you need to change this as design temperature as 200 and operating temperature as 160 and minimum design metal temperature as 0 degree, 0.1. Okay. So you need to check thoroughly once you complete the model, because manual mistakes will be there. That's why we are using checklist. So if you go by checklist, then our mistakes will be reduced, and for your lead engineer it will be easy. And pressure you can consider as 0 or 1, anything you can consider, that is not an issue. Okay. So please let me know if any other topics to be covered in the next videos. I will try to upload it as soon as possible. Yeah, and you can see the temperature now it has been changed, and the saddle temperature it is correct. So here you need to change the saddle. It is considered as an anchor, so you need to change the saddle support as Y, and